Welcome to another Earth is Our Home with Dr. Thomas Blaine. He's an associate professor with the Ohio State University Extension Program. Tom today is going to be talking about playing fast and loose with climate data. A look at how some people use characteristics of data sets inappropriately. So stay tuned. Welcome to another episode of Earth is Our Home with Dr. Thomas Blaine. He's an associate professor with the Ohio State University Extension Program. Tom, it's always a pleasure talking with you.
It's a real pleasure for me to be here.
Well, in viewing some of our earlier programs, I found it fascinating that there's a lot of statistics, a lot of different individuals saying one thing about climate change and other people saying other things. And, it'd be helpful if the listening audience sort of better understood how some people play fast and loose with climate data.
But I want to talk about a little bit more serious topic today, and it's called playing fast and loose with climate data. A look at how some people use characteristics of the sets on temperatures inappropriately. Now, I just want to make a point here. When we talk about trend analysis, and you're right when you mention that, a lot of global warming study involves the analysis of trends. Global climate change, global warming, these are interdisciplinary fields. We got atmospheric physics, we have chemistry, we have glaciology, oceanography, geology, anthropology, archaeology, history, astronomy, even. We've got all these topics. There's no such thing as just one specialist from a certain field doing global warming work. I'm an environmental economist. One of the things that means is that I'm, as an economist, I'm used to dealing with trend data, as you might expect. When you look in economics, there's an awful lot of trend data. There's trends on inflation, the stock market, unemployment, and sometimes with those trends, people try to pick out elements of the trends to make a point. And so we're going to focus today on temperature trend data and how it can be used and how it can be abused. Now, the data set we're going to look at is a data set, well, it's updated now, but you've seen this data set on Earth is Our Home. This is the main data set I go by when I talk about how Earth's temperature is changing. It's the satellite data that measures global temperatures from 1979 to the present. We've got the last month we've got is December of 2021. Now, each one of those blue dots is a monthly average temperature, and we're not talking about the surface temperature of planet Earth, because all kinds of things can interfere with that, like where you put the thermometer. This is the temperature of the lower troposphere, the entire lower troposphere, from the surface of planet Earth up to 30,000 feet. Okay, it's the area in which humans live. It's roughly the area in which there is land, because the highest peak on the planet's about 29,000 feet, as you know, Mount Everest. But I want you to look at this trend and, look at the data. Each blue dot is a month. The December of 2021, we were 0.21 degrees Celsius. That's a little over a third of a degree Fahrenheit above the average And the red shows 13-month moving averages. And the reason we do that in trends is because it smooths out the data, makes it a little bit easier to read what's really going on with the trend. Now, there are two things from this when you look at it that should be immediately obvious to the casual observer. The first is the data regularly rise and then fall in what's called a sine wave pattern. You should notice that. Look at those humps and valleys, peaks and valleys, all the way through. No matter where it is, you get that pattern. Now, that pattern is called a sine wave pattern. So look at all those ups and downs. It's a sine wave pattern. The second characteristic of this data set that should be immediately obvious is that most of the data on the left side, that is in the early period, from like 79 to 2000 or so, fall below the zero axis. In other words, it was cooler than normal. And on the right, most of the data fall on the portion that's above the zero axis. So, I mean, if you just take a look out through there toward the right of this, you see not all, but the vast majority of the data is above the axis. To the left, in the early days, it was almost all below. That's an upward trend. That's an upward trend. These two phenomena, the sine wave pattern and the upward trend, they exist for separate reasons. They're not related to each other. If you've been following Earth is Our Home, you know that those ups and downs, those peaks and valleys, are primarily caused by the El Nino, La Nina phenomenon, whereas the upward trend is caused by humans putting more CO2 into the atmosphere by burning fossil fuels and raising Earth's temperature and the greenhouse effect. So these are two separate phenomena, and they each exist for separate reasons. Now, a common strategy of people who are either misguided or deliberately trying to deceive the public, and sometimes you never know which group that person's in, is to conflate these two items, to conflate the sine wave pattern that we know comes from El Nino and the upward trend those are not related. Again, they're not related. But when you start conflating those two, you're doing what I call playing fast and loose with the data. Now, playing fast and loose with data is dishonest. It's inappropriate. You'll never see me do it on here. I work for the Ohio State University, OSU Extension, and my goal is to give you education and to be as straightforward with you as I possibly can. But that means today I've got to expose some of these strategies and techniques used in playing fast and loose with the climate data. So I want to go into that right now. So here I'm just repeating. If you've been regularly viewing this, you know that the sine wave properties, when we have an El Nino in the equatorial Pacific, you get a lot of warm water out there, and it releases that heat from the equatorial Pacific into the atmosphere and warms the temperature of planet Earth. La Nina does the opposite. There's a lot of cold water out there. We've got videos on those, and I encourage you to go to the Earth is Our Home website, the major site, and go down. We've got several. We got short videos and we've got long videos on El Nino and La Nina. As I teach this in February of 2022, we're in the midst of a very strong La Nina, which means Earth's temperature would be expected to be below trend, because the water in the Pacific is cold. It's coming up off Antarctica, spreading all the way across the equator, and it's cooling down the planet. All right, so we're in a cool phase, La Nina. The upward trend, as I said, is a separate phenomenon, and it's pretty much entirely caused by us, by what we're doing. We're adding additional carbon dioxide into the atmosphere by burning fossil fuels. Now, let me just ask you some questions. Do you think it would be appropriate? I'm going to show you the strategies. I'm going to show you what they do now. Give you a heads up so that you can spot this kind of stuff. Do you think it would be appropriate to take a look at the steep decrease in temperatures in the period from 1998 to 2000 and to conclude that we were heading into another ice age? So let's go back and look at that. 1998, look at that 1 month way up there at the top in 98, and the red line went up almost with it. But if you started a trend there in 98 and you followed it down to a very cool period in 2000, only 2 years, the temperature of the planet fell by a full degree Celsius. That's 1.8 degree Fahrenheit. Now, it's taken a whole century for that kind of average temperature to change that much, 100 years. A lot of the forecasts right now we see mean that we'll warm that much in the next maybe 60 to 70 years if we continue with business as usual. But let's say we were doing this show back in 2000, right after that data had come out, and we didn't have any of the data to the right. We just had the data up to 2000. I could get on here and say, well, the global warming, educators are all wrong. We're about to enter an ice age because if you extend this trend down, Earth's going to turn into a snowball, which if you did extend the trend down, it would have. That's true. We'd be in a snowball by now at that rate of cooling. But what has that person done? That person has conflated. We know why the temperature fell. Why did the temperature fall so much from that peak in 98 to that valley in 2000? A full degree, at 1.8 degrees Fahrenheit. It fell because we went from an extremely strong El Nino to a very strong La Nina. And yes, we have the data. We have the data on that. We have the El Nino La Nina index. We know which way the prevailing winds were going along the equator in those periods, and we know what caused that. But in the news media, you can't expect them to explain that to you, especially if there's someone who, say, does not believe that global warming is a serious issue and wants to deride it or make fun of it. They could produce data like this and argue, hey, we're going by data. But you know what they're doing? You guessed it. They're playing fast and loose. Do you think it would be appropriate to look at the steep increase in temperatures from 2012 to 2016 and conclude that we had reached a tipping point and we were into runaway warming? Let's look at that. Look at that bottom blue circle down there in 2012. 0.4 of a degree below normal. And then look at the peak just 4 years later, 0.7 of a degree Celsius above normal. 1.1 degree Celsius increase in just 4 years. If you plotted a trend line through those data, let's say that we were doing this show back then in 2016, and we didn't have the data since then. The data from 2017 out to 2021. Somebody who's attempting to scare everybody or alarm everybody could easily say we've reached a tipping point because the earth has warmed 1.1 degree Celsius. That's almost 2 degrees Fahrenheit. That's another century's worth of warming in just 4 years. And hey, the data shows that. But what have they done? They've played fast and loose, because what was going on in 2012, and if you want to Google the data on El Nino and La Nina, when that temperature was very cold in December of 2012, it was a very strong La Nina, one of the strongest, bringing icy cold water from Antarctica all the way up off the coast of Chile, Ecuador, and then out toward the Philippines, cooling the equatorial Pacific, and that cooling went into the air and cooled the temperature of the entire planet. The Southern Oscillation changed in 2015 and 2016. We went into an El Nino, one of the strongest on records. It brought the temperature up. So drawing a trend line from the bottom to the top up there in that 4-year period would be playing fast and loose. Here's another one. Does anyone think it would be appropriate to look at the data? And this one you hear a lot of. You hear a lot of this, especially in certain media. They say there's been a pause in global warming over the past 22 or 23 years. Is it appropriate to look at the data from 98 to the present and conclude that global warming has paused? So let's say you started in 98, somewhere around there, and you look out toward the present. If you do a trend line through that data, the trend line would probably be at about 0.2 degrees Celsius. It'd be a flat line. So somebody could argue that global warming since 98 has paused, that it really hasn't been an upward slope, that it's no longer an issue. It's finished. Is that appropriate, or is it playing fast and loose? So the question is, do you think it would be appropriate? No. None of those are appropriate. None of those is appropriate. Those are not appropriate. All three of those were fallacious and playing fast and loose. Why? Because there are fluctuations from trend in global temperatures. But overall, when you look at the data overall, we're currently warming at a rate of about 0.15 of a degree Celsius, or about 1/4 of a degree Fahrenheit per decade. That would mean about 1 degree Fahrenheit in 40 years. That's the current trend. Now, why use parts of the data when you can use it all? Notice what all three of those things that I gave you had in common. They started at arbitrary points in the data set. 2 of them started in 98. 1 of them started in 2012. 1 ended in 2000. 1 ended in 2016. 1 ended at the present. But what's wrong with taking a look at all the data? when you look at trends, it's okay to observe changes in the trends. That's how we know about the impact of El Nino and La Nina. But the appropriate way to determine what's happening with this is to look at the whole thing and to calculate a line of best fit through the entire data set. And if we did that, what we'd find is way over on the left side, 1979, the number would be negative 0.3. And then we would go out on the right side and look, and the number would be positive 0.3. So as you can see right now, that would mean we're below trend. Not a lot, 0.21 degrees below trend, but we already know why we're below trend. Not because the Earth's cooling, not because warming has paused, but because we've been and are still in a very strong La Nina. So again, the line of best fit, and I've specialized in doing this in economics and environmental studies my whole career, it would be a line running from the left-hand axis at about negative 0.3, going at a regular slope all the way up to positive 0.3 by the current year, 2021, the end of 2021. We'll get the January 2022 data soon. But, this is 42, 43 years or so of temperature data. We are warming at about 1/4 degree Fahrenheit per decade. So basically, I want to conclude here today by saying data trends are almost never monotonic. In other words, if you've got a downward trend, if you're on a weight loss program and you go a few months, I had a friend who lost 40 pounds in 6 months. He plotted his weight daily. He did a great job losing that weight, better nutrition and exercising. But if you plotted it out daily, it didn't fall every day, even though it fell over the period. There were certain days and even certain weeks in which he didn't lose. He actually gained a little bit. It could have been water retention or anything. And that's the way it is with any data trend, the stock market, unemployment, inflation, and temperatures. They just don't go constantly in the same direction. So be on the lookout for that. You have to consider the source when you hear someone make claims about trends. What kind of source is that? Is it the news media? You shouldn't give the news media the same credibility, I should say, as you give the Ohio State University. We're here to educate. The news media, let's be honest, for the most part, is there to make a profit. And some of the news they give is good, and some is misguided or even misleading. The key to the fast and loose examples we saw here today is that they all started from points in the data set that are essentially arbitrary. We had one that started, or two that started in 1998. We had one that started, I think, in 2012 and went out from there a few years. When you have an arbitrary starting and finishing point, that's a practice called cherry picking. And so one thing to look for when you're looking at trend data is whether people are choosing arbitrary points in the data set to make their claim, or are they using the entirety of the data set? And that's what I do on Earth is Our Home. In short, watch out for cherry picking and other tricks people use when playing fast and loose with data. Thank you very much.
Tom, I find this information really interesting, and perhaps we can, in a subsequent telecast, go more in depth. We're talking with Dr. Thomas Blaine. He's an associate professor with the Ohio State University Extension Program, who really gives a really good, fair and equal balance understanding of climate change. Tom, thank you.
Thanks a lot. Nice to be here.